So that was an excellent series of talks. So what we're going to do now is we're going to go into a 15-minute kind of Q&A session. Then we'll go into a break. But you know, there's a lot of fantastic questions that were typed up online that we're going to read those. Right before getting into that, I just want to do a quick like one sentence mini refresher of each of those talks. I think it was a really interesting series of talks because we started focusing on the fact that there's distinct observations, distinct trends that exist in these types of deposits that are very different from the classical understanding that we have of turbidites. Then we started discussing how really being aware of the dynamic evolution of processes is key to actually understanding the bed forms that we're seeing in these deposits, and how important that is to start deciphering the location that these bed forms might be in. And then we went to, we jumped to South Africa, where we actually started testing the hypothesis of where these deposits are actually occurring, where are different types of hybrid events occurring, and how can that better inform us into interpreting the depositional environment. And then again, we just now jumped to Argentina, where there was a really interesting discussion on how the substrate might be, again, interacting with the dynamic evolution that these flows are having and the implications that this would have on the resulting bed forms and overall understanding of the organization of these types of deposits. So what I'll do is I think we were going to go through and read some of the questions out loud and have the speakers answer those questions verbally. So make sure you you unmute yourselves. So the first question is for both Peter and Megan. Do you find that there's a maximum grade? And I guess this is really open for everyone. Do you find that there's been a maximum grain size that you've observed within these hybrid event bed deposits? I guess Peter, we'll start with Peter, then we'll go down the list.
Okay, maximum grain size. I guess there's several issues there. There's the sand that's incorporated in the beds, and then there's the class size, the substrate class sizes that can be meter scale in my experience for the substrate, and in a core that becomes very challenging then, because the class traverse the core and you're never quite sure whether it's actually, they're invariably more or less bedding parallel, so often it's unclear that you can underestimate the size of the event beds very easily with core traverse class. I mean, in terms of, I think the grain size is a very interesting thing in these deposits, because the upper parts of the beds often have coarser sand grains in them, in my experience, and so the debritic part of the bed is more efficient in carrying the coarser sand grains deeper into the basin. So, yeah.
Excellent. Megan, Yvonne, Andrew, do you guys have any thoughts on to add to that question?
Well, I guess in terms of the bed forms that I presented, I mean, I haven't got a very satisfactory answer because we've only really looked at one system. But in this situation, I guess what's really important is the cohesive forces for the bed forms. So I think as long as you have the cohesive strength to cause the turbulence modulation in your flow and to start producing these different mixed sand mud bed forms, I imagine you could have quite a wide range of sand grains within those bed forms.
Fair point, yeah. Absolutely.
Yeah, so speaking for the Karus, because there's not much of a grain size range anyway, we don't really see that many outsized grains, but I've been to several other basins and usually you can see these outsized grains. But I guess really your maximum grain size also depends a little bit, if you're now just keeping the big class separate, but your maximum grain size otherwise really depends on what kind of grain sizes you have in your system anyway. So that would be one of the factors limiting that.
Excellent. Ander, do you have any points to make to that? If not, I will jump to the next question, which I actually just reorganized, so I don't know which ones came first. So I apologize if I'm jumping someone's question. So one of the question that just came in from Tim Demko is he points at he asked Megan, do you think that the bed forms were ever visible on the seafloor, or were they always subsequently buried by the later fine-grained part of the flow?
That's a really nice question. Well, I doubt that these bed forms were ever really visible, because I think they're really being produced by these flows which are really strongly depositional. We see a lot of the bed forms are climbing a lot of the time. So I think as the flows continue to travel over them, they were probably very rapidly buried. And we do often see these kind of mud drapes above them as well. But definitely something interesting to think about.
And I guess kind of going along that, there was another question. Oh, too many questions keep coming in. They move. Yeah, okay, so building on that, right, there was another question or point that came out that was, because the bed forms, have a high, oh, shoot, I lost the question again. This keeps moving. Sorry, everyone. Here we go. Right, so in petroleum exploration, we've increasingly seen the effects of bottom currents on present day seabed. And so I guess, what are some thoughts out there on the effect of changing the sediment flow, or how that might be impacted by existing bottom currents? Is that something that bottom currents could actively interact with these flows and maybe flip some of those transitional switches? Because there's a lot buried in that question, but
yeah, from my point of view, I guess a lot of our understanding is coming out of basins that were the water was stratified in, and hence the deposit is unbioturbated. So the trouble, and I have looked at these sorts of event beds in more oxygenated settings that you might get if you have bottom currents, and you get very complex mix of bioturbation fabrics overprinting those H3 divisions are very organic rich generally, and you get a lot of intense bioturbation and very complex. It's very hard to read through the bioturbation often to the physical structure of the deposit. So I don't know a lot of examples where we have bottom currents actually interacting with a hybrid prone system. And I think those systems in South East Africa are interesting, and I think Pamela Sansom speculated that there may be differences between hybrid event beds and hybrid pipe flows and turbidites in terms of how bottom currents may segregate mud away from the flow into those hybrid drifts. So there's probably some information there. Anyway, that's about it for me.
Yeah, my impression is that probably bottom current can have a big effect on the substrate, like the strong bioturbation that usually is linked to drift. Maybe you can soften the substrate, and this obviously will change the way of interaction of the gravity flow to the substrate itself. But regarding the direct affection of the bottom currents, I feel the bottom currents mostly affect the turbulent cloud, like the very low density part of the flow itself. So I feel that hybrid beds are mostly typical of the gravity flow part of the event. So there will be less genetic link in terms of seeing the positional interaction with the bottom currents. That's the feeling of my experience, mostly from the East Africa. However, I'm aware that in Tanzania there are several, but I'm not fully know where could be their origin, if they are linked to the bottom currents or not.
I would add briefly that there was a really nice paper out in, I think, Geology this year by Miramontes, where they did some experimental work where they looked at how turbidity currents are influenced by contour currents. And I think they suggest that in certain situations that could be quite important.
Yeah, that paper is truly amazing, and I love it. And I think it is, you know why, but is really, really cool, and is probably one of the next trend topic in sedimentology, probably. Maybe we'll talk about that maybe in the next meeting, I don't know.
Very interesting. Okay, so there's quite a few more questions coming in. I think, one thing that's quite interesting too, that might, link, I guess, almost the 4 talks that we just saw is, right, so we understand that these are very dynamic, the flows themselves are very dynamic, right? They can go back and forth. We can, as you were saying, Meg, we can flip back and forth between those different flow regimes. And then I guess when you consider the effect that pre-existing topography might have, it'd be very interesting to see, I know the Karoo might be an example like this. Is there, depending on the topography of the basin floor or the juxtaposition of a system against, some topography, do you think it's going to be possible to calibrate our understanding of essentially, I guess, of the topography of the seafloor relative to where we are in the system by looking at these deposits, right? And I guess that's one of the things we would need to think about. To what extent would the arrangement and types of these flows might be changed by the fact that we have pre-existing topography? Could we reposition ourselves differently in the system based on that? I guess, does anybody have some ideas or thoughts or on that? I think that's one of the things that, to me, is I start thinking about this, right? Because we need to understand the impact that these might have on, positioning ourselves within stratigraphic depositional environments, and to what extent, could the signals be non-unique if we don't understand the true effect that, topography might have on dynamic flows. So I think what's, I guess, exciting to hear is that, in the first 4 talks that we've had, we've kind of hit on all the different components right now where we're looking at those observations, we're looking at the flows, we're looking at the impact. So I think it just bodes well for the larger, the larger view of these types of systems that, research is active on that. So I don't know, I think that's just a very exciting thing to see. I think we're going to do maybe 2 more questions, and then it would be time for that break. Okay, so one of the questions right here is for Peter again. What are your thoughts on the lateral changes in H subdivisions?
Lateral changes in H divisions.
Yes.
So I think in many systems we look at, there is a fairly consistent change from, the H1 down dip, expansion of H3, and appearance of H2. And then in that Ross profile I showed you, the H4 is not present up dip in that up dip borehole. And in 18 kilometers, it appears down dip. So that would be a relatively distant expression in that case. So I think there is a fairly systematic down dip expression to these things.
Excellent. Okay, and I guess this might be the last question before we take a break, but before everyone goes at the end of this question, then Emma's gonna, or Lillian's gonna make a couple points on some polls we have for y'all. But here's an interesting question from Eric Cavalli. I guess this goes out to everyone really. Do we see any good evidence of debris flows evolving into turbidites, evolving into hybrid event beds? So let's add something else into the mix, Yeah, I think that's actually a very interesting point, right? Because we kind of we try and understand, as we start linking the shelf edge down to the basin floor, what's initiating some of these turbidity currents that might eventually, that may become these more transitional flows. So I guess, might there be a predisposition of certain turbidity currents to transform over shorter length scales, depending on their initiation mechanisms? Eric, you stumped us all.
Fabien, I think, I don't know if he's in the audience, but Pete Talling might have something to add to that point, because some of his work in the Apennines actually looked at the full bed, well, Lawrence Amy as well, of course, the full bed extent and exactly where different hybrid lithophases were. But I don't know if they're in the audience.
I can't see if they are, but that is that's a really good point. One, it's a good point. Two, Eric, it's a really great question. And I think that's definitely something we can kind of hold on to, and maybe everybody can think about that a little bit more for the next Q&A discussion at the end of this. But also, maybe someone start doing some research on that. We can easily figure that out. So I think Lillian or Emma's going to jump in and just discuss. We have a couple polls for you right before everyone goes on the break, just to get a little bit information on throughout the presentation or throughout the mini conference. Emma or Lillian, y'all there?
Yeah, I'm here. Hi everybody, really lovely that you've all decided to come to this event today. So we have the first of our 5 polls we're going to release during the break. They're very simple. It's just like who you are, what your current career level is, and are you a member of SEPM, etc. We also have more polls that we'll do throughout the second half of the session, but they're more directed to like your hybrid event bed research or work. So yeah, we're just going to launch them now. Yeah, okay.
I'll also add that these are all the answers are anonymous, so don't worry. And we're really just trying to get a good calibration on how everyone's interacting with the SEPM, how they heard about this, and then trying to map out some possible next topics and where everyone's interest is lying in the larger field of deep water sedimentology and stratigraphy. So please do take the time to fill those out. They go really quick. Thanks so much. So I think what we're going to do now is we are going to take a 10-minute break. I'll hang out online while I make some coffee too, and see everybody back here in 10 minutes, which I guess will be 2:23 Central Standard Time, Houston.